So it comes in at a velocity. As it enters the atmosphere, it's starting to slow down. And then as the parachute deploys, it slows down quite a bit. And then as the sky crane rockets on fire, it just leveled up. The velocity actually just went down to zero. It just sat there, at zero velocity. It was an amazing thing. And this really kind of is the essence of what we do at NASA. It's not estimated. There are over 1 billion hits on the JPL website during the period of this landing. The world was watching, or as the JPL likes to say, they calculated 50 million voters were watching. Those things are important in a research laboratory. But the science we do at NASA really, I would give a lot of public talks as chief scientist or talks to political people or VIPs of other sorts. And I really would distill it down to this, that what we do is pursue the answers to questions that are really rooted at the core of the human spirit. Where did we come from? Where are we going? What is our place in the universe? And we accomplish this by peering at the edges of the universe, or toward the edges of the universe. Can't quite get there yet. And back toward the beginning of time as we understand it, the Big Bang. Or exploring our celestial neighbors. The fate of the planets around us hold clues to our potential fate, or how we function as a planet. Examining the sun that fuels us, the main source of energy here on Earth, and actually the fundamental ingredient to life. You all know the bottom of the food chain is plants, right? Well, actually, plants are nothing without photons. It's the sun, really the key ingredient. Understanding the planet we live on today, and the planet that our descendants will inherit tomorrow. And all of this, at least on Earth, happens in a very thin veneer of an atmosphere. When you look at the Earth from space, I haven't been in space, but spent a lot of time looking at imagery, photographs, and whatnot, and spoken to a lot of astronauts. The thing that strikes them, they consistently say, is how thin that veneer is that supports life. And this is actually blown up because the stratosphere, thermosphere, as we get higher and higher up, doesn't support life. It's the troposphere. It's that first 10 kilometers. Another aspect of the science we do at NASA is investigate the biological and physical processes in a microgravity environment. This is analogous to aging, actually, rapid aging. You remove the gravity vector, in biology anyways, you remove the gravity vector and there's an accelerated rate of bone loss, an accelerated rate of muscle atrophy. The basic physics are different. The first time I saw a picture of a flame burning in space, this actually is a little skewed. It's symmetric. You're used to the gravity effect, the buoyancy, the change in the air density, and the way a flame looks. And they're pictures of just a match with the dome of blue. It's really quite remarkable. And so I summarize this as science to inspire and science to serve. This is really the science at NASA. It's inspirational and it's useful. And I'll get into each of those in a little bit. This is the budget for NASA, the programmatic budget. So you take out what you got to spend on the people and the roads and the buildings and what it takes to make the place run. This is what NASA, the fiscal 12 budget request from the president was and how it breaks down. So the bulk of it, we've been in fiscal 13 for almost 6 months now. There's no 13 budget yet. So this is the most recent chart. The bulk of it is human spaceflight, 57%. What surprises a lot of people, surprised me when I first learned it, is aeronautics. The second A, the first A in NASA, the second letter, is 4% of the NASA budget. 4%. Education, 1%. Space technology is about 3%. And science, a little over a third. The science budget is on the order of $5 billion. It's a little less than the National Science Foundation. It's the equivalent to the Department of Energy's Office of Science. It's about 5 times NOAA's budget for science, about 5 times the U.S. Geological Survey. So it is a major science funder of research. This is the breakdown. I don't know if you can see it, but Earth science and planetary science are the majority of the investment. Astrophysics and JWST, the James Webb Space Telescope, is another sizable part of the investment. And then there's heliophysics. And what's the, oh, and then labor. Apparently, civil service didn't cost anything before 2011. We worked for free. That's why my paycheck was so small. So this is the budget breakdown. And JWST, the James Webb Space Telescope, is broken out into its own wedge when its costs really went sky high. And, you know, there's a lot of people give and get a lot of grief for the cost of the James Webb Space Telescope. But if you think about what it's trying to do, I don't know how familiar you are with it, but it's got this, I forgot what you call it, but essentially a shell or a plane to shield the electronics from the sun, because it's got to operate very close to absolute zero, about 40 Kelvin. This has to operate. And it has to operate because if it gets warmer, the background characteristics of the noise from the internal electronics start to dwarf the signals that we're trying to detect from things that are more than 13.5 billion light years away. That's pretty faint. So think about this. Trying to see signals from 13.5 billion light years away and trying to do it in a 40 Kelvin environment. Now, most of you are engineers, right? That is a serious challenge. One example, when we started building the James Webb Space Telescope, we did not know of any kind of adhesive that would retain its adhesive properties at 40 Kelvin. Little things that add up to big things and major cost overruns. Tremendous challenge, but it will be a tremendous success. It's following the same trajectory as the Hubble Space Telescope did. You know, oh, it costs too much, we can't afford it, it's crazy, who wants this thing anyways? You know, 20 years after Hubble, nobody's regretting those decisions. So my hope is that with the James Webb, the same will be true. This is an organizational chart. You don't need to read it in close detail. I have a simpler version on the next page, but I'm trying to give you a sense of how I fit in as the chief scientist at NASA. So if I break this down to simpler terms, we have the Office of the Administrator, the NASA Administrator, his Deputy Chief of Staff, a few other people. Chief Financial Officer on the left, Chief Information Officer, advisory groups, Legislative Affairs Division, Diversity, Education, the lawyers, general counsel, various other things. And the chiefs, the chief technologist, the chief safety officer, the chief scientist, officer, the chief health and medical officer, and a couple of others are on the right side of that chart. And then we have the mission directorates. The Aerospace Mission Directorate, Aeronautics Mission Directorate, the Science Mission Directorate, the Space Technology Directorate, and the Human Exploration and Operations Directorate. This is the organizational structure of NASA. Now, above us, the administrator reports and is appointed by the President of the United States. Now, I never reported to the President of the United States, but I did work fairly closely at times with the President's Science Advisor. That was my connection to the White House. And underneath us, close to 100,000 employees, investigators, contractors, people got grants from NASA. This was the foundation, you know, that we were trying to support, and frankly, the foundation that supported us. This is the NASA program. And a few of us, 7 of us, the administrator, the deputy administrator, the associate administrator, the chief financial officer, the chief scientist, the chief technologist, the associate deputy administrator. 7 of us formed what was called the Executive Council. This is the decision-making body of NASA. Now, I say decision-making body, we really were advisors to the administrator on the directions we should take, decisions that should be made on kind of the big issues. Still has to go through the White House, it still has to go through Congress, so it's kind of a starting point. But as the administrator would say, this was the group that made the decisions that if they were wrong would get us on the front page of the Washington Post. So naturally, when he invited us to support him and join this group, we were thrilled. It truly was an honor. My function as chief scientist, or my office, I built an office with a few people who joined me to reestablish this office. It had existed up until about 2003. Then it was sort of terminated as an office. And then when the current administrator came in, he said, this was important. This is one of the main reasons I took the job, because he said, I want science involved in all the big decisions. That's why I was on the executive council. That's why he had a chief scientist. I want a science perspective. I may not do what you recommend, but I will listen to you. I will take your input and weigh it with everything else. It was basically a seat at the grown-up table for science, which was huge, which really is a testimony to his commitment to advancing science at the agency, and was a major reason why I agreed to leave Colorado and take the job for a couple of years. A lot of challenges associated with doing this, though. The main ones are the budget environment is difficult. Now, I made this chart before sequester. It was difficult before. It's crazy now. Anyway, meeting the challenge of level funding. So funding amounts in the federal government, you may have heard we're on tough times right now. So things don't grow with inflation. At best, they had a saying, level is the new up. At best, you'd have level funding, so your buying power will continue to go down, down, down. The cost of access to space is tremendous. Simply getting a brick into orbit can be $100 million endeavor. Well, a brick, you can use a smaller rocket, I take it. Getting a really big brick can be a pretty substantial endeavor. Cost overruns. Nobody wants to invest in an entity that doesn't live up to its cost projections. And sometimes there weren't overruns, but there was the perception of overruns. Just bad news trickling in, and you people can't do anything right. Yet, when we land on Mars, everybody loves us. So you get what you pay for, you don't get what you don't pay for. Difficult political environment. NASA, well, I'll get to the next slide, but everybody's got a view about what NASA should be doing, and people just don't agree. And I've seen ideas that were championed by Republicans that Democrats hated, and I've seen the same ideas championed by Democrats and Republicans hated. It's a very politicized environment that makes it pretty difficult. And the last is overcommitted. This gets to, everybody's got an idea for NASA. Everybody wants NASA to go to Mars, to, send probes to elsewhere in the solar system, to fly space telescopes, to send people to the moon and to Mars and beyond. When I say go to Mars, I mean rovers initially. To study the Earth, although a lot of people don't want NASA doing that. I'll get to that a little bit later in the presentation. But really what it comes down to is that NASA is iconic. Important people, well-intentioned people, have very strong opinions about what NASA should be doing and not be doing. And they diverge. Like I said, it is about people on the moon, on Mars. Let's get out in the solar system and not waste our time in science. Let's only invest in technology that will get a person to Mars. Others, science is the big thing, the big return on the NASA investment, the best bang for the buck. Why are we trying to go to Mars with people? We're never going to settle it. So very strong opinions that result in overcommitment, because everybody sort of writes into the legislation, you should do this, you should do this. Before you know it, you got too much on your plate. Now, one of the things we've suffered from at NASA. This is from a National Academies report, sort of investigate or assessing, I guess you could call the report, what's up with NASA, what's wrong with NASA, what's the problem. I forgot the actual title of the report, but I'm sure it wasn't one of those. But their main finding, there is no strong, compelling national vision for the human spaceflight program, which is arguably, and there's a lot of arguing, the centerpiece of NASA's spectrum of mission areas. The lack of national consensus on NASA's most publicly visible mission has resulted in the lack of strategic focus. That's a harsh assessment to get as an agency, right? You haven't won people over, you don't have focus, you don't have direction. At the same time, we've built the International Space Station, the equivalent of a 5-bedroom house in orbit. It's been permanently occupied for close to 12 years now. There's always been some people on the space station. We operate in space in ways that really were unimaginable just a few years ago. It's kind of a strange vantage point sitting on that arm. I don't know. It's amazing, actually. I guess the only thing more awesome to me in terms of a place a human could be is you've seen the picture of the person with the MMU, mobile maneuvering unit, just floating out there. At least here, somehow you can feel like your buddies can pull you in if you get stuck. The MMU, you're like, here's an interesting thing. A friend of mine told me, this little basic physics for you, that sometimes as a prank, astronauts on the shuttle would, like while you're sleeping, put you in the middle where you couldn't touch anything. You're just stuck there in space and you can't reach it. So anybody guess how a person would get him or herself to the side?
Blow really hard.
That's close. Yeah, take off a shoe, just blow it as hard as you can. You know, conservation of momentum. So you throw it hard and listen to slow. I know that's true. That's what John Winchester told me. And then successfully flying out the shuttle. This is the landing of STS-135, the last shuttle. Oh, here's the end. I mean, I'd rather be on, well, actually, I'd rather be on this if I was sure it would work. If I wasn't sure, I'd rather be on an arm. This is the crew of the last shuttle mission. And then, most of you are probably aware there was, the shuttles were dispersed. Maybe you're not aware. To different museums throughout the country. I forgot which one this one was, but on its way to LA, they did a flyby of lots of places on the back of the 747 that transported the shuttle. So this is over San Francisco. The shuttle program ended, and I cannot tell you how many people said to me, "I'm sorry NASA's going out of business. I'm sorry for what's happened to our space program. I'm sorry, we must be so sad." And this was the perception. We're lost in space. And it's not that we're lost, it's that there are many things on the plate. And people will always be unhappy. It's interesting, and I'm gonna be careful with political, because this is not supposed to be a political discussion. What I will say though is the Obama administration got skewered for ending the space program, yet they actually added 2 more shuttle flights than the Bush administration planned. So the program was extended a year longer. Now, to be fair, under the Bush administration plan, there's going to be more investments in going out farther. So this is the trade-off. But people just kind of hone in. This is my Washington experience. People see everything through the political lens, through the ideological lens. And there's just no doing right, by some, and there's no doing wrong by others. That's an unhealthy situation to be in, I would argue. So a lot of people thought we're lost in space. You're too young to remember the show. Morning, maybe. But I remember it, and I was too young actually. I just watched old reruns. But if you look at the budgets, okay, people want Apollo. People want an Apollo-like program. But we spent, I think it's 5.5% of the federal budget on NASA during the Apollo era. Now we spend 0.5%, less than 0.5% of the federal budget. So you can't get an Apollo program on this kind of budget. Now, what I tell people is, don't focus so much on the magnitude, think about the integral. You know, maybe you can accumulate accomplishments, you know, if the area under the curve equals that, you know, okay, but you've got to expect it to take time. We were in a race to the moon. You know, I don't know how much you guys appreciate the whole Cold War mentality, but it was a race. It was about, you know, if we didn't win the race to the moon, we were good as dead. This is why I love the comment on Yuri tonight. You know, man, nothing lit a fire under the belly of the United States than Yuri Gagarin, his orbit in space. So he did us a big service, actually. He did the world a big service. So while people claim we're lost in space, or wonder that we are, science in the meanwhile has been a bright spot. And again, the Jumbotron in Times Square broadcast the landing of the rover. People stayed up till I think it was 1:21 p.m., watched it, were chanting science of all things. That's weird. Science. But they were. So science has been a bright spot. And, you know, I think a little less controversial than sort of the arguments over what we should be doing with our human spaceflight program. But there is some controversy, and I mentioned, you don't have to read this, I know you can't, but here's what I want you to take home from this, and I'll zero in a little later. Congress of the United States, that's the letterhead on this letter, okay? If you zoom into the last word, and I'm an earth scientist, so this really got to me. With your help, we can reorient NASA's mission back toward human spaceflight by reducing funding for climate change research and reallocating those funds to NASA's human spaceflight accounts, all while moving overall discretionary funding toward fiscal 2008 levels. So these are members of Congress who have an opinion about what NASA should and should not be doing. It certainly should not be looking at the Earth. That's just crazy. We should be sending people out into space. So one of my first assignments when I showed up, this letter greeted me, was to respond. And if you go back to the Space Act, the founding document of 1958, the first line, the expansion of human knowledge of Earth and the phenomena in the atmosphere and space. I gotta confess, until then I hadn't read the Space Act of 1958. I was thrilled to see this. The letter wrote itself as far as I was concerned. But I also want you to just take a look at the other things, because this is important. We talked about NASA being iconic. This is what the agency was created to do. This is what we still continue to try to do. Understand Earth and the space environment, aeronautical safety, and speed. You know, when I was a kid, there were two things that were very different than today. Planes crashed a lot more. It wasn't uncommon, you know, every few months you hear about or read about a plane crash. Investments in aeronautics really go up. The other thing was weather reports were totally not terribly reliable, let's put it that way. That's improved quite a bit. I mean, back then, you know, when I was a kid, the next day forecast was about as reliable as a forecast today for 3 or 4 days out. That's huge. And we owe a lot of that to our observations from space and other things. Development and operation of vehicles capable of operating in space and carrying organisms through space. How we can study aeronautic and space activities for peaceful and scientific purposes. U.S. leadership. Relevance to defense, number 6. A tool of cooperation, number 7. Using science and engineering resources to try and, well, this is a boring one. It's basically don't duplicate effort. Part of the the direction to NASA was to take or what's happening elsewhere and make use of it, don't duplicate it. But preeminent position in aeronautics and space. And so those, the top and the bottom one sort of bracket all that NASA was set out to do. I'm going to share this with you. Usually I do this with scientists, sciencey people. But one thing I learned in all of that was how you communicate controversial science. How do you get someone to understand the value of what you're trying to do when their initial posture is totally antithetical to that, or just resisting that? The first is to understand the context that shapes their perspectives, why they think the way they do. And I love this first sub-bullet. Your adversaries are not as dumb as you want them to be. We have all been in arguments, or I will bring politics in. You see this in political discourse all the time. That idea is so stupid. You're an idiot because you think that way. There's kind of a posture we want to take that if we just can't comprehend why someone has the position they have, it's easy to revert to, well, it's because they're stupid. and have that argument. Well, if you just weren't so dumb, you'd understand what I'm trying to tell you. Take the time to understand where they're coming from. Why do they feel that way? And why do some people think it's important to raise revenues by taxing the wealthiest Americans, while other people think it is ridiculous to raise revenues that way? We end up hurting ourselves because if we don't tax these Americans, they'll invest it in the economy and everybody wins. And there is legitimacy to both arguments. You can't just revert to, that is the dumbest thing I've ever heard. You may end up there. But don't start there. There's strength in this posture. Frame things in a way that resonate. When you're talking to someone, when I talk to people about climate change, I don't say, a lot of times what they're hearing is this guy wants me to impose clean energy standards on factories, and it's going to cost a fortune, and my district is going to be pissed and I'll never get reelected and a runaway effect. What I would usually say is, look, there's value to understanding what tomorrow will bring. We can all agree on that. And that's a common starting point for the conversation. Well, let's talk about what tomorrow will bring. How do we learn what it will bring? What affects what tomorrow will bring? And you can have a conversation that doesn't immediately put someone in a resistant posture and get them thinking you're as dumb as that first bullet suggests. Don't tell people what to think. Whenever you're in an argument, do not tell people what to think. Tell them what you think and why. And acknowledge that their beliefs are rooted in values. Again, it's not that they're stupid or that you're stupid. It's that you have values that take you to different places. Start the conversation from there. Don't expect your values to change their beliefs. Okay? Find what's common and build a conversation around that. This, are you, most of you undergraduates? Yeah, okay. So, I usually say this to the PhD scientists who just kind of like, we think we know everything, we're just waiting for people to get wise to our ways. But these are just good tools for discourse. Okay? So make note of this. And finally, don't be outcome-centric. Don't be so focused on getting a certain outcome. Focus on having the conversation. Let the outcome follow. It may not be what you want, but these are the things I learned in Washington about how to discuss controversial topics, and they apply to anything. So when you're off in your jobs as engineers or whatever it is you ultimately end up doing, keep this in mind whenever you're in a controversial type of conversation. But back to NASA. Really all we do, and when I would try and make the case for science, it's about trying to understand the universe, our surroundings, and our place in it. How we can live in it, how we can function in it. And by it, I'm including Earth. I'm not talking about simply going to space. And that's rooted in perspective. Looking at deep space, the Butterfly Nebula, which is art as far as I'm concerned. I saw just some of the most beautiful images. Or other planets. Anybody seen this image before?
Oh, yeah.
So you've seen Earth, the blue marble, or sorry, the pale blue dot. Blue marble is when you're up closer. Here's just the pale blue dot. And I think this is incredible. Oh, I guess I have it. When you look at the Earth in this way, it's different. It's a different Earth. Well, it's the same Earth. You view it different. And part of that also is having a fleet of satellites that look back at the Earth itself to try and understand how and why it's changing. So we look out, we look in. We grow out, we travel out into space, and we look back. This is what we do at NASA. This is what our best minds are trying to do, and not simply our science minds, but our engineering minds. Our best accountants, for that matter. I mean, it takes everybody. Now, I'm going to move on to my discipline, just spend a few minutes talking about it. So I study ice. Yeah, what I tell my kids, Dad, watch ice melt from space. That's my job. I use satellites to study ice. So if you look at the polar regions, you know what I hope this animation impresses upon you is that ice does not operate simply in isolation. I agree. People say no pun intended. You know the pun was intended. I really didn't mean that. You know, it's part of an interacting system. Okay? The sea ice on land grows in the winter, shrinks in the summer, and you can see how it flows through the ocean. There's the exchange of energy, momentum, moisture, salt. As ice forms, it rejects salt to the surface of the ocean, which affects ocean circulation by changing the density stratification. The sea ice in the ocean is an energy barrier. It blocks energy transfer between the atmosphere and the ocean. This affects weather. This affects ocean circulation. And if you go, I think we're going to come around to Greenland again. The ice on land, I think the Canadian ice cap's coming up. The ice on land holds the equivalent of, Greenland holds the equivalent of about 7 meters of sea level rise. Antarctica about 58. Oh, it's stopped. I'm going to take you back to Greenland. So we study the characteristics. How much is Greenland dumping into the ocean? So it's all connected. The presence of ice on land, the ice in the water, affects the ocean atmosphere exchanges, affects the ocean circulation, atmospheric circulation, sea level, coastal relationships. I haven't even brought in clouds and precip and other stuff. It is an interconnected system. And really, to study it, you need the space-based perspective to look at the elements of the system working together. Now, alternatively, some of us go there, and I love this because to me this screams graduate student. Right? That's what you get to do in graduate school. But if you look closely, they're smiling. They're having But I put this up because this really tells very clearly why we use satellites to understand the Earth system, in particular the Arctic, the Antarctic. It's about context, scale, and perspective. Let alone access, danger. It's dangerous to do some of this stuff. But really, it's looking at ice in the context of other changes. And from a perspective that allows you to look at the whole thing, or at scales that allow you to look at the whole thing. So these poor guys are a little speck in the Antarctic sea ice. Now when we look at the Arctic and we watch that growth in the winter, shrinkage in the summer, one of the things we track is the summer minimum. Okay, so around September, roughly 19th I think it is, the ice has shrunk to its smallest level and then it starts to grow back. This is the perennial ice cover, the thick hardy stuff, okay, that survives the summer melt season. Over time this has been shrinking. and it's been shrinking very rapidly. And if you look at it goes only back to 1979 because that's the start of the satellite record. So we have a 30-plus year satellite record, which in satellite terms is actually a long time. The 1979 to 2000 average of the minimum is yellow. But if you look at the graph, you look at 2000, it was up until this past year, it was a record in the satellite series minimum. And it was the area covered in white. So as this ice, it's just shrinking more and more and more. Human civilization has never known a time where the Arctic was ice-free. Yet we seem to be on our way to that state. Now, one reason I show this is because that area in yellow right here, anyone know what that's called? In sailing terms, it's the Northwest Passage. Okay, for a long time, people thought, man, if we could navigate the Northwest Passage, eastern United States to Asia would be a much shorter route. You know, it's the possibility of navigating over, shipping over polar routes, save a lot of money, provide a lot of access to resources. And in 2007, a 76-year-old retired hog farmer from Minnesota sailed the Northwest Passage in 73 days with his wife in a boat called the Cloud 9. 73 days. Now, some people who know nautical history know that this passage was sailed before, in 1903, by Roald Amundsen, but it was actually 1903, 4, and 5. That's how long it took. And I can't help but think that Amundsen is looking at the ghost of Amundsen is looking at these people in their Cloud 9. I'm sure, his boat, I like to think was probably called, what was I thinking? It sucks. Damn, it's cold. It was actually called the Fram, which I think is Norwegian for this sucks. Anyway, the point is, it's a shift. Okay, it's a different time. Okay? And the satellite view is allowing us to realize this, to quantify this, to look at this in relationship to other things. Now I'm going to zoom in here. This is Antarctica as viewed from space, just far away without a lot of fidelity. But some of the tools we have allow us to look more closely. You know that ice flows, glaciers flow. Okay, now when we switch to synthetic aperture radar interferometry, if you want to know what that is, I'll tell you later. We can track the flow of ice, and it reveals the rivers, what's flowing fast, what's flowing slow, what's feeding each of these ice streams. And we can track the acceleration or deceleration of these ice streams and begin to understand the contribution of Antarctica and Greenland in a similar way to sea level. So this is a little hint of my science, understanding the changes in ice cover and what space is telling us, what the space-based perspective is telling us about that. Now, before I wrap up, I just want to touch upon a few of the more memorable moments. The first one is a negative one, but it's Washington. It's a wonderful country because we have something called the First Amendment, which lets anybody say anything, and the internet lets them say it loudly to a liar. So when I was appointed, there was one particular blog, there were several blogs, but this one caught my attention. My name is Waleed Abdullahi. From the name, you wouldn't know I was born in New Jersey, but people make assumptions about that. In fact, when I was a junior engineering student at Syracuse University, we had a lot of Middle Eastern graduate students. I went to the dean's office to find my class ranking. And I walked in and I said to the secretary, I said, I'd like to find out my class ranking. My name is Waleed Abdullahi. She said, she leaned into me, she goes, you speak English very well. I said, thanks. It's a little something I picked up in New Jersey. And I thought that was the end of it. But, you know, years later, I'm chief scientist at NASA, and the blogosphere is abuzz with things like the Obama administration picked an Arab whose surname indicates he might be Muslim. But it's not certain, as its top scientist figures. My mother was a Baptist. I wanted to call this lady and tell her. My mother was a Baptist. I was born in New Jersey. What are his politics? What is his background? His bios all over the net are carefully cleansed of such information. And it leaves a huge question mark. I don't know any scientists who put on their bios, you know, I'm a Democrat or I'm a God bless the First Amendment. On the other hand, maybe he keeps his nose out of Arabist politics, which would be a good thing. But I doubt it. Well, welcome to the world of visibility. Another memorable thing is just how hard the job was. And I came across this comic. I just liked it. Neil Armstrong. I had the privilege of meeting and giving a presentation to Neil Armstrong. And there were Neil Armstrong, Buzz Aldrin, Michael Collins, and so the 3 Apollo 11 astronauts, and John Glenn, of the Earth, were all receiving the Congressional Medal of Honor, and they stopped by NASA the night before, and the administrator called me up to his office and said that we were going to meet with these guys, and I mean, it was a thrill. I sat there, and you know, I was just thrilled. And anyone who's seen me give a presentation before knows I have a story. This is true. When I was a kid, my best friend, Matt Perry, and I would pretend we were the Apollo 11 astronauts, the 2 of them. And we'd start in his kitchen, we'd drink Tang. And we'd leave his kitchen and walk across his lawn like in slow motion, like you see on TV, and wave to people. And we'd walk to his shed, and he'd bang around in the shed. You know, we did a countdown, we'd bang around the shed like we were taking off in a rocket. We'd, you know, spend a couple minutes just banging back and forth. It was a lot of Tang. We were kind of and we'd stop, we'd land. We were on the moon. You know, and we'd open the door to the shed, and there was our lunar landing right there, and Matt's back there. And it was his Tang, his yard, his shed. He was Neil Armstrong. But I got to be Buzz Aldrin, which was cool. You know, so I let him go out. And occasionally, this is true, kids are mean. Occasionally a third kid would join us, and we would let him be Michael Collins. We would shut the door to the shed. Just leave him. So meeting these astronauts was really a thrill. And I went to Neil Armstrong's memorial service when he died in Washington. It was beautiful, it was spectacular. Very moving. And Gene Cernan, who was the last man to walk on the moon, did a eulogy. And he said, this is just a nice story. He said, you know, when the Apollo 11 astronauts returned, I don't know how much you know, but the original landing site was too rocky. So Armstrong went and found another place, and the fuel was taken down. He had about an extra 60 minutes worth of fuel to go find another place, and you know, it was ticking down. And he got down to seconds of fuel left. And Gene Cernan, the eulogy, said, you know, when he got back, I said to him, Neil, you were so calm. You know, it was so intense. We were going nuts on the ground, and you were so calm. And Gene Cernan said, you know, Neil looked at me and said, well, everybody knows when the gauge reads empty, you still got a little bit left. I did have the privilege of meeting Michael Collins. I did not share with him the story, I just shared with you. That was really fun. This little girl, her name is Clara Ma. She named Curiosity. It was a contest, and she came up with the name, and she was just a beautiful, sweet girl. And I met her at the launch of Curiosity. And I really wanted to meet her. I was excited about meeting this kid who came up with this name and wrote this great essay. And so like, all right, I'm gonna meet Clara. So I went and introduced myself to her, and I said, I'm Walid Abdulani, waiting for the "your English is very good" response, but she didn't give it to me. And I introduced myself. I said, I'm Walid Abdulani, and I'm the chief scientist. And she's like, oh my God, you know, her knees started shaking, like she was meeting the chief scientist, and I'm like, I get to meet Clara. Really sweet girl whose stars in her eyes. And every now and then we get a letter from kids. This was a great part of the job. Toby here wants to know if there's carbon dioxide in space, because if there is, we can send seeds up there. Plant seeds on the planet, water, like on Mars and the Moon, and sunlight, because plants take in carbon dioxide, and the planet would need an atmosphere. Then there'd be oxygen, and then people could live. I love this, you know, there's these little 6-year-olds or 7-year-olds that just get thinking, or they write to me, so whenever something like this would pop in and, you know, show up in my mail, it was a thrill. Watching the last shuttle launch was amazing, or as some people call it, the end of the space program. Anyone know what this is?
Dragon.
Dragon capsule, right. You know, I was at the launch of the capsule, and then I watched the birthing while from Washington. And it was amazing. This was a monumental achievement. A commercial entity taking cargo to and from the space station. And, you know, this is a cornerstone of what the current space program is about. It's trying to empower entrepreneurs, creative people like Elon Musk, to do this kind of thing. Now, Elon Musk also started Tesla Motors, and so after the Dragon returned, he had a party in Washington, and it was my first billionaire's party. They're different than other parties. And you know, we showed up, and there's a beautiful red Tesla in front with a beautiful model, just, you know, pointing to it. And you know, the fancy car showed up, and we showed up in our government vehicle, and we just switched the fleet from sort of a black sedan town car-like thing to Ford Fusions, hybrid. So we show up in our Fusion, parked by the Tesla, wait for the model, and walk. But it was incredible, because this is a monumental moment, actually, in the space program. Monumental. It's a change in doing business. When I left, I got a nice presentation from the NASA administrator. All of those are pins from each of the shuttle missions. So the ones I had been to, the ones when I was an engineer, was when Challenger blew up. And, well, I was in college, and the return to flight, I worked at General Electric, and I snuck out to the main building at the main entrance, because that was the only one where there was a TV, and I watched the launch of the return to flight following mission 2.5 years later. So to see those pins there really meant a lot to me. Almost there, but just touching on a few ones. This is my daughter, Jada, one of my daughters. At the launch of Mars, Clara and I were not the only celebrities there. will.i.am was there. He was thrilled to meet us. And he did a wonderful thing, actually. What you see in the upper right, Leland Melvin is the head of the Office of Education at NASA. Leland is an astronaut, or was an astronaut, and a professional football player. A couple of boyhood dreams. The nicest guy I've ever known. You know, just wonderful. Doing great things for education. And he and will.i.am have become friends. will.i.am is very interested in STEM. So he wanted to come to the launch, and he wanted to do a private concert for a few people, a couple hundred people. The workers associated with the message. So my daughters were thrilled. My older one is 13. She was just in heaven, you know, to be able to get her picture with him and post it on Instagram and all that stuff. And, you know, she had a little trouble with my transition to Washington. She missed Colorado, missed her friends. And after this, she pulled me aside, just, Dad, I want you to know that today was the best day of my life. And I think you do have a cool job. And I'm sorry, it's time to wind down. I'm just about done. This was the landing of curiosity, just amazing. A lot of emotion, a lot of energy, a lot of sweat and tears went into it, and to see it successfully land was spectacular. The last thing I'll end with is this iconic Earthrise image from Apollo 8. This was Life magazine declared it the most influential photograph of all time. Because when you look at the Earth in this way, you can't help but view it differently. And that's what we were really about at NASA, was looking at the Earth in different ways, creative ways, compelling ways, to see its beauty and try and understand it, how it works, how it's changing, how we fit into the cosmic arena. So really being a part of this organization absolutely was and remains a real privilege. And for that, I'm sorry I went a little long, but I'll stick around and take questions as long as you got them, but I certainly won't be offended if you bolt. Thank you. I always hated when speakers went long, so I'm sorry. Get sucked up in my stories. Yeah.
You mentioned that you dealt with a lot of back and forth in the politics and everything, especially working within NASA and higher up. How'd you deal with that? Because it's very tasking.
I dealt with it in kind of with the guidelines I had laid out on that chart with a lot of words on it. You start by understanding everybody's got a job. Everybody, if you're going in position as everybody's trying to do some good, and you just have different ways of realizing that good, or different definitions of good, you can put up with a lot more crap. And I do think people were sincere and working in earnest, and we may just see things differently. Sure, yes, it's kind of naive to just think everybody's functioning honorably and with everyone's best intentions at heart. There is a lot of maneuvering, a lot of posturing, and a lot of ugliness about how stuff looks. But once you kind of accept that that's what it is, and you put your energy into trying to make it work, trying to secure it in a way you think is useful. And maybe steer isn't the right word, but my goal was not the outcome as much as it was the conversation. And when you go into it in that way, often the outcome is more likely to follow. But if you're just focused on, in this meeting, I'm going to get you to think that, you're not going to go anywhere. So I think I was good at building a reputation as an honest broker of sorts, somebody credible who would tell you the flaws of what we were trying to do as well as the good things. And I think people saw that and responded to it, and that made it less taxing. Sometimes I'd be just frustrated, like you would believe, but usually not. Yeah.
Now that companies like SpaceX here in Nevada and Virgin Galactic are taking over some of the more traditional roles in NASA, lifting things into space, bringing people into low Earth orbit, where do you see NASA going in the next 10, 15 years, 20 years, in terms of their overall focus, no longer lifting things up, they're going to be doing what?
Well, this is where you get back to the lost in space thing, because there's a lot of disagreement on what that should be. The current plan remains an asteroid. Now, an asteroid is the next step. An asteroid was thought to be a good destination because of kind of a stepping stone to going to Mars. You wouldn't have to invest in a 2-year mission, to get to Mars and back. You could do it in a short amount of time. As we've learned more, it turns out asteroids are about as challenging as Mars because they aren't as plentiful or as close. You have, when you want to go to an asteroid, you have to find an asteroid that's got the right spin rate. You have to find an asteroid that's got the right trajectory so that your mission duration is reasonable. I almost cracked up the first time I heard someone say, and it has to be bigger than the spacecraft that you go to it with. There it is. Just bring it home. So there's been some evolution in the thinking about that, I think. But ultimately, humans to Mars is where people are headed. The question is just what's the best path to that?
So the Inspiration Mars mission is still slated to launch either 2018 or 2030 for the proper window. What is NASA's opinion on that? Is it a free return?
Very supportive. I think, an entity like Inspiration Mars can assume a risk posture that NASA can't. We simply, there are just things NASA can't do as a government agency in the execution of our responsibilities. But the more successful commercial entities are, the better it is for the nation and for NASA. So NASA, let's say they were successful, we would shift our focus, back up. Landing becomes paramount, the next thing would allow us to, and I say us like I'm still there, it's just in me, I'm sorry, but it would allow us to accelerate what we're trying to do and take advantage of the advances made by industry. And nobody wants industry to be successful more than NASA does. Yeah.
Do you believe a commercial entity or NASA will be the first to put a man on Mars?
I believe NASA will. I think, I may be wrong, I'll be the first to admit that, but I think the business model doesn't support a commercial entity doing it. It's, sending a person into space, you can get billionaires to finance that, but, an undertaking that's hundreds of billions of dollars, it's just, I think, too hard to do commercial. There was a hand up there, and, yeah.
Yes, you showed how you're monitoring the levels of ice caps at the Arctic. Are you prioritizing the detection of methane emissions, and have you seen any?
No.
Because I heard that's like
not prioritizing it. Well, let me back up. There is a set of airborne campaigns that's looking at carbon emissions, methane, and other sources from the Arctic tundra and the area. So there are airborne activities. We don't yet have the capability of doing it from space. So these are just done by aircraft.
Okay.
And I don't know what they're finding yet. It's still kind of early in the program.
So what are the direct return effects that happen inside NASA when a failure occurs? Maybe one of your examples is Columbia disaster. What happens?
If humans are involved, it's very different, obviously, than not. I was not at. I was at NASA when the Columbia tragedy occurred, but I was not high enough to hear the conversations behind the closed doors. But a few things happen. The first is obviously just sympathy, shock, because these are people that many of the members of the NASA family work closely with day to day, and they're gone. They're trying to do something that moves humanity forward. So there's that. There are kind of two aspects. There's the emotional. How do you honor the people for what they did? How do you mourn the loss? And then there's the technical. How did this happen? What were the failure modes? Why didn't we know it? Why didn't we see it coming? And a very, I think, intense internal scrutiny as to what led to that. With Challenger, and Challenger was the Rogers Commission, Columbia was the Columbia Accident Investigation Board. You just bring in the best minds in the country and have them have at it. You throw back the covers and let them look wherever they want, talk to whoever they want, ask whatever they want, because everybody wants to know why and how to avoid these. But the fact is, it's dangerous business. And
GRACE, which is basically gravity measuring mission, are used for, spatial study of features like, say, Greenland ice sheet, whereas the same thing can be done at a lower cost using just high resolution imaging.
It can't be done with high resolution imagery. The way GRACE works is it detects the anomalies in the gravity field. So you have the two satellites. This is my ice sheet. You have the two satellites flying at some distance, and as the first enters the local gravity field, it accelerates and the distance increases, and then here the distance closes back up, and we measure the separation to determine something about the mass below. And as time goes on, that separation is either increasing, if this is growing, or it's decreasing if my ice is shrinking. So what imagery can tell us is how fast ice is flowing, but it can't tell us the mass or the water in the water table, the depletion of aquifers. This is all below the surface. The movement of masses and water masses in the ocean. So GRACE is unique because it detects, can infer mass movement from changes in the gravity field. You can't get that with
Just to add into that, when especially talking about spatial mass distribution, can you not just use a combination of, high resolution imagery and altimetry? Wouldn't that just give somewhat the same result?
It would give some of the same results, especially in oceans. We do use the altimetry because the mass movement is expressed in a volume or topographic change. But in things like the depletion of aquifers, the imagery doesn't tell us anything because it's all happening below the ground. There is an ongoing discussion about whether gravity is better for ice sheets or altimetry. I was the lead of the science team for the altimetry mission, so I'm a fan. But I think GRACE is amazing. It's phenomenal. So, there are arguments for both. And GRACE actually, compared to a lot of other missions, is pretty low cost, especially because the Germans contributed pretty substantial elements. Yes?
How do you see international cooperation happening in the future of spaceflight?
It's hugely important. It always has been, but it's hard because we have our annual budget cycles and people fight over this and fight over that, and so it's difficult for us to commit. And one example is up until a year and a half ago, we had a partnership with the European Space Agency for the next Mars rover with drills and the next level, and the budget process forced us to withdraw from that. We have to go year by year. The European Space Agency has to get all its member nations to agree, and to do that, they work on a longer time horizon. So once they were in, they were in. Once we were in as long as budgets would permit, and maybe next year the budget won't permit, and that was the situation we found ourselves in. So it is essential, and 9 times out of 10, it's mutually beneficial to a great degree, but then that 10th time comes and it's tough. Those were hard conversations. Yeah.
So if our budget doesn't allow us to continue on with the project, does NASA have to scrap some projects or scrap projects at all?
Yeah,
midway through?
I mean, we get a budget from Congress, we get direction on what to spend it on. The phrase is the president proposes, Congress exposes. So the president puts forward a budget, and Congress deliberates that, and then passes what is the budget, and tells us you got to spend money on this and that. There's a certain amount of flexibility in there, but when we get a big overrun on a mission and our budget is flat, it's got to come from somewhere. So sometimes we choose to cancel things. Sometimes external forces tell us to do it. Sometimes you can slow the development of some things to solve some financial problems and others, but it's a zero-sum game. So the president proposes and Congress disposes. The president's budget is late this year, and Congress still hasn't passed the last year's budget, so it's good theoretical exercise. Yes?
So could we talk about government launch vehicles? So if it had Constellation project, as far as I was
You know, as far as I know, it's pretty far along.
Yep.
You know, billions invested, and they canceled it, and now it's the SLS. You know, you talk to someone at NASA, they're gonna be super positive, and be like, oh yeah, you know, it's gonna fly. But, you know, realistically, looking back, I mean, the public hasn't changed. It's not like the public necessarily wants, you know, this government launch vehicle any more than they did, you know, 6 years ago. And let's say we have a balanced budget, you know, cut 1.4 trillion. You know, just like, I think aerospace should just cease to exist. It's a really negative kind of topic, but you know, it's what I'm
Yeah,
thinking about.
I don't think so, because there's enough, I come back to my statement about NASA being iconic, and there are enough people in powerful positions to ensure that something will go merrily on. And when the Obama administration came in, the priority was commercial crew and empowering commercial industry to take over the lower orbit operations so we could do other things. The Senate, and this was ultimately agreed to by all parties, but the Senate looked at that and said, whoa, you're NASA. You're going farther. You're not just going to stare at the low Earth orbit, you know, and you have had a senator from Florida and a senator from Texas who needed this, believed in this, you know, would not be doing justice to their constituencies if they didn't pursue this. So, you know, there is enough interest, I think, and enough in the human spirit that says we've got to keep reaching farther, that I think we'll always keep it on the table. It may vary in shape and form and level of investment. You won't get that Apollo budget curve that we saw before, but I don't think it will end. I think it will always be there at some point. And actually, the multi-purpose crew vehicle, the SLS multi-purpose crew vehicle, are not that different constellation. You know? So there is drawing resources, but you know, there'll always be some that say it's a waste of money, and some that say this nation needs it. And I don't see it going totally one way or another. It'll always be somewhere. Yes.
So as a career question, you know, becoming the chief scientist is not the most common career path that people take.
I think there've been like 7. The joke, you know, there've been 300 astronauts. How many chief scientists? It's more special.
Exactly. Yeah. So what I was wondering is, what unique things happened during your career that made you become selected for that position?
I'm gonna level with you. So I was an engineer, got my bachelor's degree in mechanical engineering, and I was a bad engineer. I was not good at it. It didn't feel right. It didn't match me. And I thought, you know, what I really wanted to do was trajectory analysis in orbit mechanics. So I thought, oh, I need to go to graduate school to do that. So rather than design and build satellites, which is what I was doing, I went back to graduate school thinking about astrodynamics. I was in CCAR here. And somewhere along the way, I happened to just learn about what the satellites were actually looking at. And that really energized me. I got really interested. Oh, this is cool. You're looking at the Earth from space. And I took a class from a guy who went to Greenland a lot. I ended up working for him and went to Greenland and, you know, the Arctic, the Canadian Arctic, and, you know, and the core of my career trajectory is rooted in one thing, and that is, and remember this, I wish someone had told me. I had the honor of giving a convocation speech at my alma mater at Syracuse University, so I got to tell the engineers the things I wish someone had told me. The core of it is, it's got to energize you. If it energizes you, you'll have the energy to put the work into it to excel. If it drains you, it's wrong. You should be doing something else. And when I was a design engineer doing analysis, it just drained me. I just wasn't into it. And I was sitting in a class, and I was like, oh, this sounds cool. Like, I can really do this. And I went and learned more about it. So because of that, I put a lot of energy into doing it well. And it's a mix of just effort and luck. And I had the opportunity. I got a postdoc at Goddard. And so I poured my heart into that. I got hired on as a civil servant, and at the time I was in grad school, I went to Greenland with one of the program managers at NASA. And when he retired, something he saw in me made him think I might be good at the job, so he recommended me for that job. And while I was in that job, I did some work with the chief scientist at the time, and some other higher ups, because the ice was changing and there were a lot of questions about it. You know, I just, people got a sense that I was thoughtful in what I did, that I really put my heart into it, and that only happened because I was energized. Add to that the fact that my approach was always, you know, to assume there was value in everybody's perspective, and they may not agree with what I'm thinking, but at least have a respect for people. I gained a reputation as being someone who was easy to work with. And, you know, there were a number of serendipitous events, but when this administrator was looking for a chief scientist, the biggest challenge for science at NASA at the time was communication. You know, I'll be the first to say I'm not the best scientist, I'm adequate, but my strength is in communication. And he talked to people, and from a number of directions, he heard my name, and he called me. And, you know, so it's a mix of luck, you know, serendipity, but none of that will happen if you're not energized by what you do. It's if you'll indulge me, it's amazing. The thing the most valuable lesson I learned in college, I learned in a human sexuality class. And it was, apart from the whole safe sex thing, it was, the professor did a great thing. The class had like 400 students in it, and he said, you all have questions about sex that you're embarrassed to ask. So everybody write down a question you want answered on an index card, and at the start of every class I'll read 3 and answer. And so there are some predictable questions, but one of them was, how do you know you're really in love? And he said, and this, you know, so when you're in college and things are intense and feelings are intense, it's hard to sort of discern when you're in love or when you're just obsessed with something. It's a fine line, right? And he said, when you're in love, it energizes you. When you're not, it will drain you. It was a very simple advice, and very true. You know, when you think about it, your healthy relationships are ones where you just felt good. You couldn't wait to see the person. Your unhealthy relationships were, oh, what am I going to do? They're not here, you know. And I took that to everything I did in life. I think that's true. If it's right, it will fuel you. If it's wrong, it will draw from you. And if that's your guiding principle, if that's your compass, you'll have the tools to excel. I can't guarantee you the same luck will follow that I have, but that is the foundation. Add to that being nice to people, because you never know who's going to go where. And you know, to me, those are the ingredients for success. By the way, human sexuality is the most popular elective among engineers. Guys. Yeah, feel free to head out, but if there are more questions, I'm fine sticking around a little bit longer. Yeah.
How does NASA balance the risk versus the reward of the mission? Curiosity had a very risky abandonment, but the reward was staggering. Sure. How do you think that with future missions? How do you say, is it worth the risk of trying to make this attempt to push the boundaries?
That's a good question. We usually do a risk assessment and determine, is it manageable? You know, are there steps we can take to minimize the risk? But we get our guidance from the scientific community, gets together and articulates science priorities. And we, the agency, try to implement those. And so a big priority is understanding the habitability of Mars. It's among the top priorities of the planetary science community. So they spoke clearly, we need to understand this. This is what's most important in science. Can you do it? And you know, the NASA posture is, of course we can do it. Just give us a little time to figure out how. And you know, I think with curiosity, we may not be able to guarantee success, but we could guarantee foreseeable issue was studied. You know, it was the most studied mission that NASA, unmanned NASA has ever launched. So there's no clear answer to your question, but it's simply, we're mostly concerned about making sure we take prudent steps to minimize that risk, but it will always be there.
How much more severely do you take risk in missions that involve human flight as opposed to robotics?
Oh, we take far less risk with human flight. I don't remember where I read this, but it's easily sort of 2 orders of magnitude in terms of the reviews, the scrutiny, you know, the flight review boards, the safety reviews, the technical reviews, all of those things. Yet, we still go well. You know, but we have sort of, I don't remember how they categorize these in human spaceflight missions, but in science missions we have class A, B, C, D, E. A class A mission is nothing's gonna go wrong with this mission. We'll spend a lot of money to make sure that's the case. Class D is, look, we're only gonna spend this much and we recognize it may not work as efficient, you know. Human spaceflight is class A plus plus plus, you know, it's just a whole other level.
And where did Curiosity fall on the same scale?
Well, because it was, I think, roughly $1 billion, it was a class A mission. Doesn't mean things can't go wrong, but it means we will spend the money to make sure we've, you know, looked under every rock to make sure there weren't problems. Anything else? You guys are good, you got staying power, yeah.
So is so with the Mars 2020, like the reused rover or whatever, so is Europa kind of off the table now because of that then, or?
Kind of. I mean, there's only so much money to go around, so unless someone can get creative and propose it under what's called the New Frontiers cap, we have discovery missions, which are the cheapest, New Frontiers, which are medium class, and then the directed missions, which are Mars, Europa, other things. You know, unless someone can fit it into the New Frontiers window, or unless in the next decadal survey, which will take place about 8 years from now, it percolates to the top, it's off the table for the time being. Yep.
How much have you seen conversations change in the past couple weeks after, like the asteroid events? Or if you have at all?
Oh, in Russia?
Yeah.
Yeah.
Well, Russia and the close by.
Yeah, yeah. I haven't, only because I have not been functioning in those circles anymore. I'm sure they've changed. You know, the asteroid thing is weird. It's one of these really low probability, ultimate catastrophe kinds of things. How do you manage that? How do you talk people into spending money? So, Schweiger, Rusty, Jack Schweiger, and the B612 Foundation is, you know,
Yeah,
really
Rusty
working
Schweiger.
hard to, that's right, Rusty Schweiger. Really working hard to garner the resources to do this. And, you know, even, it's funny, Congress told us to do it, but they aren't giving the money. Told us to do the survey, the inventory of the asteroids. The way to do that is you put a satellite in a Venus trailing orbit so you can see space, basically, what you can't see from low Earth orbit. But I suspect on the Hill in Congress there's a little more attention paid to this, but I really don't know. There's a bit of a whimsical aspect to Washington, you know, hard to believe. You know, an event like that does shape people's thinking, but at the end of the day, people still have the core values and they're difficult to perturb. Anything else? Yeah.
Continuing to a previous question about Europa, when you say that it's going to be an expensive mission, like along the lines of a Mars mission, are you saying a lander mission which?
No, even orbit. The deep space missions, well, Juno, going to Jupiter wasn't that. No, actually, no, it would be late, I'm sorry. You can get there.
So can we not just for the time being just have a precursor mission to a future landing mission by just having a remote sensing?
You can, but is that worth the money? And that would need to successfully compete against other ideas sort of in the same cost class. We do a lot just through competition because it's a mix of how compelling the science is and how technically feasible it is. And how much of a cost risk is it. So the Juno mission, which orbits Jupiter and then we'll just go into it as far as